Hi everybody, welcome to lecture number 12, LAN Redundancy. In this lecture, we are going to discuss about a very important protocol which is called STP, Spanning Tree Protocol. So, which is a layer 2 protocol. It is going to eliminate loops, loops in among the switches. So, it is a very important protocol. So, there are some steps available. So, how it is going to work. There are different types of STP available. So, all these things we are going to discuss in this particular lecture. So, it is a very important lecture, technically speaking a very important lecture for the networking students. Now, so let us start LAN redundancy. Now, I am giving you two topologies here. In the first topology diagram, there are two switches available, switch 1 and switch 2. They are connected by using a single link. In the second topology, the same thing, I have two switches. I am connecting these two switches by using two links. Now, if you go for the first one, in the first topology diagram, so I connected just by using a single link. Suppose if there is any failure, so if this cable is not working or any reasons, because of some reason, so this particular cable is not working means your network, that means the first PC cannot communicate with second PC, so it will be divided into two segments. So, a single point of failure is going to make your network down. So, that is the first topology diagram. Now, what I am doing means, in order to have a safety or a security point of view, I am going to have one more link like this. So, now there are two different links available. So, why I am doing like this means, suppose if one link is failed means I can use the other link for communication. So, the vice versa, the first one if it is failed, second one is going to work, second one if it is failed, the first one is going to work. So, for a safety point of view, I am going to have redundancy. So, this is the redundancy concept. Now, in redundancy, there are some advantages available, and at the same time, there are a lot of disadvantages available. So, what is advantage means? If a single point of failure, suppose if a failure happens in a link means, we no need to worry about that, the other link will be used for communication. We can use this link for communication. This is the major advantage. If you see the disadvantage, what is the disadvantages means? So, here there will be a loop created. So, what is a loop means? Some frames forwarded by S1 to S2, the same frame may be forwarded by S2 to S1. So, this is called a loop. So, switch 1 forwarding something to switch 2, the same thing may forward to S1, that means the switch 1. So, there is a loop will be created in this case. So, if the loop is created, there are a lot of problems will come, that means your network performance may go down, it may affect the MAC address table of the switches. So, there are a lot of issues available, technically speaking there are plenty of things available, the drawbacks we are going to see what is that one by one. Now, to solve this particular issue, this loop problems, in order to solve these loop issues, we have a protocol, a layer 2 protocol, that is the STP, Spanning Tree Protocol. So, the Spanning Tree Protocol, if you enable S1 and S2, switch 1 and switch 2, if you enable the Spanning Tree Protocol, we can avoid these loops. So, in this lecture, we are going to discuss about what is redundancy, then we are going to discuss about what is a Spanning Tree Protocol and how the Spanning Tree Protocol is working, what are all the different types of Spanning Tree Protocols available. So, these are the things we are going to cover in this particular lecture. Now, I am going for the redundancy concept. Redundancy in in the layer 2 switch networks. Now, so it is a very important concept, but it is a very important. Redundancy is very important for the safety point of view, for eliminating single point of failure. So, if there is a failure in one place, one link, so automatically you can use other link. So, you can avoid, you can prevent the disruption of your network services. So, this is the major thing. Now, so additional physical path, it will give you an extra additional path, and also the logical redundancy will be available. Physical redundancy, logical redundancy, it will be available. So, the same point we already discussed this. So, it is going to provide a alternative path for you. in case of any problem in your network, so automatically you can avoid the network disruptions. Then if you are going for the redundancy, automatically there are a lot of chances available for loops. So physical and logical loops may occur in your network. So we need a loop-free topology diagram. Okay, your topology should be a loop-free. If you are having loop, there are a lot of other issues available as we already discussed. Then if there is a loop available means automatically there are a lot of issues available, even it may affect your network performance. Okay, your network may go down, so your MAC address table will become full. Okay, CPU utilization will be more. Okay, so there are a lot of overhead available, so we have to break this particular loop. So how we are going to break the loops, we will discuss it in the coming slides. Now I am moving to the next concept. The next concept is spanning tree protocol. So it is one of the very important protocol. So this protocol is going to avoid, or it is going to remove the loops. Okay, so spanning tree protocol is a loop prevention network protocol. Okay, so it is a loop prevention network protocol. So this is going to provide us a loop free layer 2 topology. Then spanning tree protocol logically blocks, it is going to block all the physical loops in a layer 2 network, and also it is going to prevent the frames from circling the network forever. So the loop forever, so it's a very interesting concept. Okay, infinite loop. So you can avoid infinite loop in layer 2. Okay, so you can see this is an example here. So there is a loop available between these 3 switches. If you take, there is a loop available here. Okay, so this is a loop, it will be created like this. So what it has done here means they just block this particular port, they blocked here. So they removed this particular link. Okay, so they put it as inactive, or we can say it is blocked. So once it is blocked means automatically there is no loop. Okay, you have only this particular option. Okay, so this is a simple example for spanning tree concept. Now spanning tree recalculation. So what is recalculation means? So in an unexpected way, okay, we already blocked this particular link. Okay, you take this 3. Okay, so I am taking only these 3 switches. So spanning tree protocol already it is blocked this particular link. Okay, it is already blocked. So unexpected, okay, in an unexpected way, so there is a break. So this particular link goes down. There is an issue available in this link, and this link is not working. So in that case, automatically there will be a recalculation. STP protocol is going to do the recalculation, and it is going to open this particular path. It is going to open. So this is called recalculation concept. Suppose if there is any issue available in the network, based on that your STP protocol is going to do the recalculation, and it is going to open that blocked ports. Okay, so it is going to unblock the blocked ports. Okay, so this is the concept. So STP recalculation available. Now, so issues with redundant switch links. In this slide, we are going to discuss about the issues with redundant switch links. So because of redundancy, what are all the issues available? We already discussed there are some advantages also available, and at the same time there are lot of disadvantages also available. Okay, now so because of the path redundancy, so it provides multiple services, multiple network services, by eliminating the possibility of single point of failure. So we already know this. So if a single point is failure, you no need to worry about it. Okay, you can have a redundant link, that means another path, alternative path. So you can use the alternative path for communication. Okay, then multiple path exists between the 2 devices. If there is no spanning tree protocol, if the spanning tree protocol is not implemented, so automatically there will be a layer 2 loop. So the loop will occur. Then, so a layer 2 loop can result in, there are a lot of issues I already told you. So there are a lot of issues come. Where is that? The first issue you can see, the MAC address table instability. So instability in MAC address table, that means your MAC address table will be filled with the same information, okay, the same entries, okay, it will be, that means we can say it is repeated entries will be available in the MAC address table. Then link saturation, then your CPU will be utilized, that means the CPU of the switches will be utilized more, and also the end devices. Then the resulting your network will become unstable. So the entire network will may go down, your network performance will go down, your network will become slow, okay, the bandwidth will be consumed. So lot of issues may happen then. So Ethernet does not include a mechanism layer 2, that means if you have loops, okay, there is no special mechanism to what to say, to block the loops, to break the loop in layer 2, okay, I repeat the point. In layer 2, suppose if any loops happen, there is no different technique or no, okay, mechanisms to block that. But if you say routers, suppose in routers, okay, we are having a loop means, okay, automatically the loop can be, okay, it will be like closed, or it will be like what to say, it can be eliminated by using a concept called TTL. Okay, we are having TTL concepts in the packets. Now the TTL value will get reduced if it is crossing a router for each hop, so it will be reduced by 1, -1. So automatically if the TTL value reaches 0, your packet will be thrown out from the network. But this types of concept is not available in layer 2. So we need a protocol there. Okay, I repeat the point. In layer 3, we have a concept of TTL. So the TTL value, for example, the TTL value is 100. So there is a loop between two routers. So automatically if it crosses one router, it will become 99, okay, 98, 97, 96, okay, automatically the value will be reduced, the TTL value in the packet. So whenever the TTL value becomes 0, okay, if it reaches 0, okay, in the packet, automatically the packet will be thrown out. So we don't have any such concept in layer 2. In the data link layer, so there is no such concept. So because of that, we need a special protocol, or we need an additional protocol, okay, to break the loops. So that protocol is the STP protocol, Spanning Tree Protocol. Okay, so you can see the same points available here. So in the IPv4, IPv6, that means in the layer 3, we have the concept called TTL, time to, okay, time to live. So in every packet, the TTL value will be available. So the TTL value will be decrement, it will be keep on decrement. That means it will be less. That means they are going to reduce this value. So whenever it reaches 0, so automatically the packet will be thrown out. Okay, automatically the loop will be closed. Okay, this is the thing. But if you are going for layer 2, we don't have such mechanism here. So what we have to do means you need some protocol, some specialized protocol we need. So that is the STP protocol. Okay, Spanning Tree Protocol. So these protocols used to prevent the loops. So loop prevention mechanisms at layer 2 Ethernet. Okay, so this is the concept. Now we are going for the next one, layer 2 loops. Almost the same points repeated here. You can see in the previous slides. So what are all the points we discussed there? The same thing is available here. Okay, so what does that means? If there is a loop in layer 2, okay, how it is going to affect your network? So we already discussed. So your network may go down. So it may affect the performance of your the overall performance of your network. So the MAC address table will become full, or there will be a instability in the MAC address table. Okay, CPU utilization. So these are all the points. So we already discussed about these points. So you can kindly go through this particular slide. Now the next one, I'm moving to the next slide. It is broadcast storm. So what is a broadcast? So broadcast storm means receiving a huge number of broadcast packet in a particular time. So within some few seconds. So if your network is receiving a huge number of broadcast frames. Okay, so that is called the broadcast storm. So broadcasting, Okay, broadcasting, you may aware of it. What is broadcasting? So broadcasting means it is one to all. In a network or in a subnetwork, okay, a single machine is going to be the source and the destination is going to be all the hosts in a network. So that is called the broadcast concept. Now, so if you have broadcasting issues in your network, so automatically the network performance may go down. So you must know what is a broadcast storm. So broadcast storm means a huge number of broadcast packet sent, okay, sent in a network. So over a period of time, so or within few seconds, okay, this is going to be the broadcast storm. So how these broadcast storms, okay, happens, or what are the reasons behind this means there are so many protocols. Suppose ARP protocol, okay, so you can see here ARP request. So due to the ARP request, okay, address resolution protocols, so ARP request may create broadcast storm in a network, and also, okay, some failures. Suppose if a network interface card, okay, a hardware problem such as the faulty network interface card or some loops, so this all may create the broadcast storm. And also multicast also, not only the broadcasting concept, multicasting also can create the storm, okay, broadcast storm it can create in the switches. If you go for IPv4 networks, we have these issues. That means the broadcast storm issue is available only in the IPv4. Okay, in IPv6, completely the broadcasting concept has been removed. Okay, so we don't have the the broadcasting concept in IPv6. Okay, so we have only unicast, multicast, okay, and anycast. So broadcast has been completely removed from the IPv6. Okay, so this is again because of the broadcasting. So there are a lot of issues will be available. So the first thing is the bandwidth of your network will be affected. Okay, the overall performance of your network will be affected. Okay, the MAC address tables. So everything, whatever the issues we already discussed in the previous slides, the same thing you can write it here. Now, so you need spanning tree protocol. So the spanning tree protocol, it may control the broadcast storms also. Okay, so it may control the broadcast storms. Now, I am going for the next important thing, the spanning tree protocol. The spanning tree algorithm. So spanning tree algorithm was invented by R. Perlman, okay, in 1985, okay, almost 35 years back. So it's not a new concept, but at the same time you cannot avoid this. Okay, we cannot avoid this because spanning tree protocol is a very strong protocol. So it is must. By default, in all the switches, spanning tree protocol is enabled. Okay, so you can say this. R. Perlman in the year of 1985. Yes, okay, in the year of 1985, so he published a paper. So title, an algorithm for distributed computation of spanning tree in an extended LAN. So spanning tree algorithm, so what is the main purpose means it is going to create a loop-free topology diagram in layer 2, and also it is going to have the first step. We can say the first step of this spanning tree algorithm is selecting a root bridge. Okay, we are going to see this in the coming slides. So what is a root bridge, how to select a root bridge and all, we will discuss it later. Then, so it is going to prevent the loops, it is going to avoid the loops completely. Okay, then it is going to block. Suppose if it is a loop, means it is going to block the particular port. You can block the particular port, and you can do the recalculation also, and you can open the port whenever you want. So switches running STP are able to compensate for the failures by dynamically unblocking. So this is the point I told. So there will be a recalculation concept is also available. Suppose if your port is blocked, means due to the spanning tree protocol algorithm decision. So whenever you need, you can open it. Okay, so a recalculation also available, and they can open the blocked ports. So this is a simple introduction to the spanning tree protocol. So we can see in the next slide. Spanning tree algorithm. So what are all the steps? So this is a very important thing. So basically there are 4 different steps available here. Okay, steps, or we can say as the 4 different phases. So you can say anything. Okay, the first one is, the first important step is selecting the root bridge. This is the first step. Then the second one is block the redundant paths. Then create a loop-free topology, and finally recalculate in case of link failure. So these are the 4 different steps. So we have a group of switches, okay, a group of switches I'm having. So in that group of switches, okay, a particular switch will be selected as a root bridge, okay, it will be selected as a root bridge. So that is the reference point. So that particular switch is the reference point for the entire topology diagram to build the spanning tree around. So selecting the root bridge, this is going to be the first step. So how to select, we are going to discuss in the coming slides. Okay, I have 4 switches in my topology diagram and there is a loop available. So I want to select one switch as a root bridge. So how can I select means there are some steps available, we will see it in the coming slides. So once the root bridge is selected, then you have to find only one logical path between all the destinations on the network, okay, to the root bridge. This is the point. So there should be only one logical point. This is the second step. We are in step number 2. First step, selecting the root bridge. So one person I selected as a root bridge. Okay. The next step is for all the other nodes. You have to find only one logical path. Okay. So between the node and the root bridge. Okay, between the root bridge and a particular node, all the other things you have to block. So if there is more than one path available means, okay, only one path you have to take, the other path you have to close it. That means the protocol will automatically close, but this is the second step. Then the next one is a blocked port has the effect of making the link non-forwarding. So once if it is blocked, automatically it is not going to forward any packets in that particular port. So you have to check, that means automatically it will check only a single path will be available to the root bridge. So this is the third step. The fourth step, suppose if there is any failure available, okay, if a particular path is not working, so now it will do the recalculation and the unblocked ports may open again. Okay, it may open the unblocked ports also. So these are all the overall idea. Okay, so if you want, I can just repeat it in few words. That means let me summarize. So first thing, selecting a root bridge in your topology diagram. Okay, just assume we have 4 switches. So in that 4 switches, one will be selected as the root bridge. Good. The second step, now from the root bridge to all the nodes, you have to identify the paths. So there should be only one path, a logical path. Okay, only one path should be available. If more than one path available, okay, the secondary, that means the second path and third path should be closed. Then fourth one, we have to decide which port should be closed in a switch. What are all the ports to be closed in order to have a loop free or in order to have a single path. Then automatically your spanning tree protocol started working. The next one is, suppose if there is any issues available, okay, unexpected issues available in a non-blocked ports, okay. So in that case, okay, it will recalculate. That means the spanning tree protocol will recalculate and open the unblocked ports. That means the blocked ports it will unopen. Okay, that means, sorry, I repeat, the blocked ports it will open. Okay, so this is going to be the fourth step. So this is the overall idea of the spanning tree protocol. Now, so we can see in the next slide steps. So what are the steps means? Steps to a loop-free topology. That means spanning tree algorithm, it is going to build a loop-free network, okay, a topology for us. So what are the steps? The 4 steps is given here. So the first step is electing the root bridge. The second one, elect the root ports. The third step, elect the designated ports and elect the blocked. Okay, that means the alternate ports. So these are the 4 steps that we already discussed, but now only the terms are changed. Okay, now, so these are the 4 different steps your spanning tree algorithm is going to use. Now, before going for each and every step, a very important thing we are going to discuss now. So during this STA, STP, that means spanning tree protocol functions, a special frame. Okay, the switches, they are going to exchange a special type of PDUs, protocol data units, they are going to exchange. So what does that means? That is called BPDU. Okay, so bridge protocol data unit, a bridge protocol data unit. So they are going to share this information, okay, about themselves and their connections. So I have 4 switches, means all the 4 switches, okay, are going to exchange this BPDU, okay, frames. So what is available in this BPDU frames? Okay, or what? Okay, 2 things we have to answer. What is available inside this BPDU? This is the first question we have to answer. Then what is the use of this BPDU? Okay, bridge protocol data unit. Okay, what are the uses of this? Now I am going for the first one. So the first one is, what is the use? Means this BPDU are used to elect the root bridge, the root ports, the designated ports and the alternative ports. So everything. So to elect the root bridge, to elect the root ports, to elect the designated ports and to elect the alternative, okay, ports. So for all these things you are going to use the BPDU only. That means the spanning tree protocol is going to use. Okay, then what is available inside that? Okay, what is available inside a BPDU frame? So now BPDU is going to consist of, okay, it is going to consist a bridge ID. So this bridge ID is used for selecting the root bridge. Okay, so the bridge ID is available. Now the bridge ID is involved in making many of the spanning tree algorithm decisions, including root bridge and port roles. So this is going to play a vital role. Okay, so the bridge ID is going to play a vital role in selecting the root bridge, root ports, designated ports and the alternative block ports. Okay, what is this BID? So what is a bridge ID means? So it contains many things. So what are they? The first thing is a priority value, the MAC address of the switch and the extended system ID. So there are 3 things merged together. A priority value. So we are going to see in the next slide what is a priority value, okay, what is the MAC address, okay, we are going to discuss. So priority value plus the MAC address of the switch and the extended system ID. Okay, so all these things are combined together, that is going to be the bridge ID. Okay, now lowest bridge ID value is determined by the combination of these 3 fields. Okay, so this is going to be the combination of these 3 fields, it is going to give the bridge, the BID value. Now, so the 3 things, priority value, bridge priority, then the extended system ID and the MAC address. So these are the 3 things which are used for calculating or for finding the BID. Okay, now go to the MAC address. So we already studied about the MAC address in so many places. So MAC address, it is a layer 2 address. We can say MAC address, we can say physical address, you can say hardware address. Okay, there are different names available for that. So many names. Now, so what is the length of the MAC address means? The length of the MAC address is 48 bits. So we can use the MAC address is a part of BID. Okay, so bridge ID is available. Now, if 2 switches are configured with the same priority value, okay, we are going for the priority here. If 2 switches are configured with the same priority and have the same extended ID, so there are 3 things, so bridge priority and extended system ID. If these two things are same for 2 switches means, then they are going to see the MAC address. What is the MAC address? So the lowest value of the MAC address expressed in the hexadecimal number, so that will be the lower BID. So whatever the lowest one, it is going to take, okay, among these 3. Then extended system ID. So what is an extended system ID means? The extended system ID value is a decimal value added to the bridge priority value, okay, in the BID to identify the VLANs for this BPDU. So it is going to be something like some ID, some decimal value added to the bridge priority value. So we are going to discuss in the, okay, as the first one, and it is going to identify the VLANs. Okay, so whenever you are having any VLAN, okay, automatically the extended system ID will be used. Now, so we are going for the bridge priority. So it's a very important one. By default, the priority value for all the Cisco switches is the decimal value of, okay, the decimal value 32768. So that is the default value. The range of bridge priority value, so it could be from 0 to 61440 with an increment of 4096. Then, so a lower bridge priority is preferable. So if the bridge priority is less, then the importance, okay, it will be selected, chances available, it will be selected as the root. So if the priority value is 0, automatically, so it is going to, okay, a bridge priority of 0 takes the precedence over all the other bridge priorities. So that means if the value is less, automatically, so it will be considered. So this is how the BID will be calculated. So based on the three things, one is the priority value, MAC address and the extended system ID. Now I'm moving on to the next one. So the next concept is how the STP protocol, spanning tree protocol is working. So we are going to see with an example. Now we are going to discuss an example for STP. So spanning tree protocol, how it works. Okay, we are going to see by using an example. So you can see there is a topology diagram available. So this is a topology diagram. So there are three different switches available, switch 1, switch 2 and switch 3. Now, so there is a loop, okay, so you can see there is a loop available here. So between these three links, okay, there is a loop available. So we have to avoid the loop, or we are going to avoid the loop by using the spanning tree protocol. So the spanning tree protocol is going to close a particular port here. Okay, any one of the port, it is going to close it. So once if it is closed, automatically the loop will be removed. How the STP is going to work and how it is going to find the suitable port for blocking. Okay, so that we are going to discuss now. Okay, so the first thing is we have to select the root bridge. So there are three switches. So all the three switches, they are having their own BPDU, that means bridge protocol data unit, you can see. So this is the BPDU for the switch number 2 and this is the BPDU for the switch 3 and this is the BPDU, that means bridge protocol data unit. Now, so every switch, it is having their own bridge ID in that. So bridge ID, so it is consists of three things we already discussed. One is the priority, bridge priority, then extended system ID and MAC address. Okay, so these are the three things. Now you can see the priority is available, MAC address is also available, this is a MAC address, but extended system ID is not available. But what is extended system ID means? By default, all the three switches, they are going to be in VLAN 1. Okay, so by default, all the switches are going to be in VLAN 1. So 1 is the extended system ID. Okay, 1 is the extended system ID and 32768. So 32,000. Okay, 32,768. This is the default priority value. Okay, so 32,768 is the default priority value. Then by default, all the switches are in VLAN 1. So the extended system ID, what is the extended system ID value means? The extended system ID value is 1. Then the default bridge priority is 32,768. So now, so these two things will be added. So if you add this, so 32769, okay, you can see, so 32769 is the priority value. Now for this switch also the same thing, 32769, so this is the priority value, but for this particular switch the priority value is 24,577. Okay, actually this is 24,576. Okay, it is going to be 576 plus 1 is added. Okay, that 1 is the extended system ID. So 1 will be added because they are in default value, that means the default VLAN 1. Now, so what is the first step means? so the first step of spanning tree protocol is choosing the root bridge. So how it will select the root bridge means based on the priority value. So the switch which is having the less priority value, okay, so whatever having the less priority value, it is going to become the root bridge. So in this case, if you see, so the switch 1, S1 is having the less priority value. So the priority value is 24577. So this is very less comparing with the 2. Okay, so comparing with this 2, so automatically, so switch 1 will be selected as the root bridge. Okay, so this is step number 1. Then second step is one more thing. Okay, so what is it? The other point means default bridge IDs. So we are using the default bridge ID. This is what I already explained in the previous slide itself. So the default bridge ID is 32768. Okay, this is the default bridge priority value. So with that, the 1 will be added. So why 1 is added means because by default all the switches are in VLAN 1. Suppose we are having different VLANs, VLAN 2, VLAN 3, VLAN 4 if you are creating. So based on the VLAN ID, that means the VLAN number, okay, automatically your priority value is going to change. Okay, so this is the concept of the default bridge ID. Okay, now the next one is, the next point here is, you have to determine, okay, we are going for the second step. So what is the second step means? The second step is electing the root ports. Okay, electing the root ports. Now, so in order to elect the root ports, so what you have to do means you have to calculate, that means the STP, spanning tree protocol, is going to calculate the root path cost. Okay, it is going to calculate. So what is the root path cost means? From the bridge, so we selected the root bridge, from the root bridge to all the nodes, that means to all the switches, we are going to find what are the different paths available. Then for every path, okay, for every path a cost should be calculated. Okay, the cost should be calculated. Now if I go to the previous slide, you can see we selected S1 as the root bridge because, okay, the priority value is less. Now from S1 to S3, what are the different paths available? Okay, it is going to find. Then from S1 to S2, okay, what are the paths available? Okay, it is going to calculate. Then for every path, okay, it is going to find a cost value, a path cost value will be calculated. Now in this case, if you take from S1 to S3, we have only one path. Okay, this is the only one path. Okay, then from S1 to S2, there are two different paths available. Okay, that means this is one path, then this is going to be the other path. Okay, the another path. So there are two different paths available. Now from the root bridge to all the nodes, okay, so what are all the possible paths available? For every path, the cost will be calculated. Okay, now so this is going to be the root path cost. Now how to calculate the root path cost means, so we are going to follow, that means if it is a Cisco device, okay, if it is a Cisco device, for the Cisco devices, the root path cost will be calculated, okay, by using IEEE 802.1d standard. Okay, so there is a standard available. We cannot, just like that, we cannot put the cost value. So there is a standard available. So what is the standard means? It is 802.1d standard. Okay, so which is also known as the shortest path cost for STP protocol and RSTP protocol. So this is the table. Okay, this is the table. So this table is, okay, 802.1d standard. So this is what we are going to do. So depending upon the speed, if the port is 10 Gbps ports, so the cost is going to be 2. So 1 Gbps, it is going to be 4. So 10 megabits, 10 Mbps, 19. So sorry, 100 Mbps, it is 19, and 10 Mbps, it is 100. So this cost is going to be fixed. Okay, it is going to be fixed. So then based on this particular cost, so the root path cost will be calculated. Now in the next slide, we can see we are going for the second step. So we already decided switch 1. Okay, switch 1 is our root bridge. Okay, this is our root bridge. So I just mark it in yellow color. Now from this, okay, I'm going to have different paths. Okay, for example, if you take S3 to S1, there is only one path. So we can directly calculate what is the cost. So based on the speed of fast Ethernet 0/1. Then I am going for S2. So for S2 there are two paths available. So this is path number 1 and this is the path number 2. Okay, you can just follow this. So this is the path number 1 and this is, or you can say path number 2 and this is path number 1. So there are two paths available. Okay, now so what is the cost of the path means? Okay, you can say for the path 1 the cost is 19. For the path 2 the cost is 38. So why they use 19 here? So if you go to the previous slide, you can find it. So 19 means, that means the speed of the interface. The speed of the interface is 100 Mbps. So they use 19. So this table is going to help you to find the cost. So here for path 1. Okay, they are using fast Ethernet 0/1. So the speed, what is the speed of fast Ethernet 0/1 means it is 100 Mbps. So it is going to be 19. So I am taking 19 as a cost. So here 19 into 2, there are two ports it is going to cross. So 19 into 2, it is going to be 38. Now, so we have two different paths with the cost. So path 1 is 19 is the cost value and 38 is the path value for the second path. Now, so automatically we have to choose the best one. So what is the best one means whatever the less value. So that means from switch 2 to switch 1. So this path will be selected. Okay, so this path will be selected. So this is the the path will be selected. Then we have to select the root ports. Okay, we have to select the root port. So how to select? Okay, first we have to identify the paths. So only two options. Okay, you can see whatever in yellow color is a path for us. So this is the path from S2 to S1 and this is the path from S3 to S1. So only these two paths we are going to use. Okay, now we have to choose a very important one which is called the root ports. So what is a root port means? A root port is a port closest to the root bridge in terms of overall cost of the root bridge. So which is very close to the root, the root bridge. Now, so S1 is the root bridge. So here this FA 0/1, fast Ethernet 0/1. So this is my root port. And then here, so this is fast Ethernet 0/1. So this is close to the root bridge. Okay, I'm going to select these two as the root ports. So this is the step number 2. Okay, so second step we have to elect or we have to find the root ports. Then the next one, third step. I'm going for the third step. So what is the third step means? The third step is elect the designated ports. Okay, this is step number 3. So designated ports, how to select the designated ports means, so the designated port has the best path to receive the traffic leading to the root bridge. Okay, you can see this is the point. So the designated port, so I may use a different color. So yeah, the designated port has the best path to receive the traffic leading to the root bridge. Okay, so what is it? So come to our example. This is our root bridge. We already selected this as the root bridge. Then root port. This is the root port and this is the root port. Okay, so this is the root port. Now we have to select the designated port. So designated port, you can see, is a port on the segment that has the internal root path cost to the root bridge. That means it should have a path to the root bridge and also it should be the path receiving traffic leading to the leading to the root bridge. So it should lead to the root bridge. That means it is going to focus on leading to the root bridge, and this is also it is going to leading to the root bridge. So now I'm going to say this is going to be my designated port. So the port that has the best path to receive the traffic leading to the root bridge. So this is going to be I'll just make it in a different color. Now this is my designated port and this is my designated port. These are the two designated port. Now in this link, so in this link FA 0/2 will be selected as the designated port. This is the designated port. So this is step number 3. In the step number 3 we are going to find the designated port. Okay, so if it is, I'll give one important point here. Okay, so a shortcut, if it is a root port, definitely the opposite will be a designated port. Okay, the opposite will be a designated port. So this is a root port, this is the designated port. So this is the root port, this is the designated port, and here, okay, which is leading to the root bridge. So this is the designated port, and here this is going to be the designated port. Now, so this is step number 3. Okay, now moving on to step number 4. So what is the step number 4 means? You have to block. So what you have to block? So a particular port you have to block. So how you can block means, if it is a root port, leave it. If it is a designated port, leave it. Okay, suppose if it is not coming under any of these things, that port you have to block. Okay, that port you have to block. Now you can see, so this is, okay, in this topology diagram, in the same topology diagram, so this is the root port, this is the designated port. So this is the root port, this is the designated port, and this is the designated port which is leading to the root bridge. Now I selected this as the designated port, so automatically the other end, it is going to be the alternative port. That means this particular port will be blocked. Okay, so this will be blocked. So once if this blocked, automatically the loop will be avoided. So S2 is going to use only this particular path, so it cannot go through, okay, S3 and S1. So this path is now blocked. So now completely there is no loop in this topology diagram. Suppose if there is any problem for this link, for the trunk 1, if there is a issue, okay, sometimes the cable, okay, is not working, or any technical issues happen, automatically the STP protocol is going to calculate, and it will open this alternative path. Okay, the alternative port will be, it will be open, so that the traffic will move in this particular direction. That means from S2 to S3, S3 to S1. Okay, so this is how we are going to elect the alternative blocked ports. Okay, now in some cases, okay, while selecting the root port, okay, you can see the root port. That means the step number 2. Okay, step number 2. So while selecting the root port, sometimes you may have equal cost distance. Okay, so that means multiple equal cost path will be available. So in that case, how we are going to select? Okay, how we are going to select the the root port? How to select the root port? So now you can see if the cost value is same. So in that case, you have to go for the BID. Okay, that means the bridge priority, or the sender port priority, or the lowest sender priority ID. So you can use any of these 3 things, okay, to identify the root port in case if you have the multiple equal cost path. Okay, so this is the important concept. So up to this we are understanding, okay, how the STP protocol is working. So the main concept here is we have to avoid the loops. So there are 4 different steps available. So starting from, okay, finding the root bridge to the last step is blocking. Okay, selecting the blocking port. So that means the designated, the alternative port. So up to this, there are 4 steps available. So this is a very important concept and a very important question also. Okay, exam point of view. Okay. In this example, we are going to discuss about how to elect a root port from multiple equal cost path. Okay, so you can see the topology diagram carefully. So in the topology diagram, okay, so S1 is selected as the root bridge because the bridge ID is less. Okay, you can see the other bridge IDs. So if you compare with all the bridge IDs, the bridge ID of S1 is very less, so it is selected as the root bridge. Now the next step is, okay, root port. So root port means, so automatically F0 is the root port. Okay, it is selected as the root port. Now, so I'm going for the path. Okay, so from S3 to S1 we have only one path. S4 to S1 we have only one path. So there is no issues here. But now if you are going for S2, switch 2, there are 2 different paths available. Okay, this is path number 1 and this is the path number 2. There are two different paths available. Now both the paths are having the equal cost. Okay, so multiple equal cost path. So in that case, which path the STP protocol is going to calculate. Okay, that is going to be the important point. So in the previous slide we discussed. So there are three different parameters it is going to use. One is the lowest sender BID, or lowest sender port priority, or lowest sender port ID. So these are the three different parameters it is going to use. So now in this case, so which one we are going to use, which parameter we are going to use means lowest sender BID, bridge ID will be used. Okay, now you can see this is S2. So for S2 everybody is sending the BPDU, bridge protocol data unit. That means this S4 is going to send the initial step. I am talking about the first step. BPDU, bridge protocol data unit. So S4 is sending its own BPDU to S2, and S3 is also sending the BPDU to S2. So now in these two BPDU, so whichever is the less BID, bridge ID, it will be selected. So if S3 is sending and also S4 is sending means automatically in this which is going to be the less means the bridge ID of S4 is going to be the less. Okay, you can say this one and this value. If you compare these two values, automatically the bridge ID of S4 is less, so it is going to select this particular path. Okay, this is the concept. So if you have multiple equal paths, so which particular path you are going to select means to find the root port. So we have to go for three different parameters. So lowest sender BID, lowest sender port priority, lowest sender port ID. So based on the three things you can select. So in this case we are using the lowest sender BID concept. So here automatically the switch 4 is selected because this is having the less BID, and this path will be selected for S2. So then you can go for all the steps. All the 4 different steps you can apply now. Then I am going for one more example. So this is a very interesting example. You can see from S1 to S4 there is a loop available in this case. Now we have to close a particular path. Then only we can avoid the loops. So which path we can close, or which link we can close, or which port exactly we can close. We have to find it. Now I am checking the bridge IDs. So the bridge IDs you can see this is 24577 and this is something 3276. So in this case the root bridge S1 is going to be the root bridge. Then from S4 to S1 there are two paths available. For both the paths we are having the equal cost. We are having the equal cost. So now I have to choose any one path from this. So what is the concept I can use means I can go for the first step, lowest sender BID. I can go for the lowest sender BID. So if I go for the lowest sender BID concept means the lowest sender BID is going to be the root bridge. It is a root bridge. So now, so in that case, so both, that means I'm here. I'm in the S4. I'm in S4. You just think now S1 is sending the BPDU, that means bridge protocol data unit. So it is sending the bridge protocol data unit here, and also in this particular link it is sending the bridge protocol data unit. So I receive BPDU frame from S2 in both the links. So both the bridge ID value will be less. So there is a tiebreaker here. That means we received the BPDU. Just assume this is the BPDU packet from S1 and this is the BPDU packet from S1. So here the same value will be available. That means the bridge ID value will be same. So in that case we cannot take any decision. So there is a tiebreaker available. So that means tie. That means equal. That means the bridge ID is going to be equal. So in that case, I cannot select, okay, that means the lowest sender BID is not going to work. Now, we are going for alternatively, we are going for the last concept, okay, that is lowest sender port ID, okay, port ID or port priority. So you can take anything, port ID also you can take, port priority also you can take. In this example, I am going for port priority. The next example, I am going for the port ID. Okay, there are three different cases we are discussing now. So now we are going for the port priority. Now, if you see the port priority also it is going to be same here. Okay, so you have to see the port priority as the second. The first one is the sender BID, that means the bridge ID. So sender bridge ID is matching, it is going to be equal here. Okay, so I cannot go for the BID concept. Now I am going for the port priority, that is going to the second concept. So here the port priority is also the same value, 128 is available. So in that case also there is a tiebreaker, I cannot choose, I cannot find, okay, I am not going to choose which path I am going to use, we cannot. Now I am going for the third one. So the third parameter what I am going to use means I am going to use, okay, the third one, that is a port ID concept. Okay, now what is the port ID? Sender port ID means you can see here in this example. So S1, okay, S1 is sending a BPDU, that means bridge protocol data unit, okay, the packet is coming here. Now what is the port ID means? The port ID here is fast Ethernet 0/1, that means sender port ID. Then here, okay, I am going to receive a packet, that means a BPDU, a bridge protocol data unit. So here the port ID is going to be 02. Now in this, whatever the less I am going to choose. Okay, so here F 0/1, so this value is going to be, okay, is less, so automatically path 1 will be selected. Okay, path 1 will be selected, so the other path only we are going to close. So where we are going to close, that is a different thing that we already discussed. Okay, you have to first you have to identify the root port, then you have to identify the designated port, then you have to go for the alternative port, okay, or DE. So root port, designated port, and then alternative port. So now you can see in this case, this is the root port and these two are the designated ports, and finally this is the alternative port. The alternative port will be blocked. So this is how we can choose the root port when you have a a situation, okay, with multiple equal cost paths. So in this slide we are going to discuss about spanning tree protocol, timers and port states. So here in this slide only timers, so ports, okay, we are going to discuss in the coming slides. Now, so there are three different types of timers. Okay, STP is going to manage, or it is going to require, or it is going to manage three different types of timers. The first timer is a hello timer. So hello timer means it is the time interval between the BPDU. Okay, that means a bridge protocol data unit. Okay, so the time between that. So by default it is 2 seconds, and the administrators can modify, okay, between 1 to 10 seconds. So that is a hello timer. So the second timer is forward delay timer. So this is the time spent in the listening and the learning state. So in the next slide we are going to discuss about the states. What are all the different states available, port states. So the time that is spent in the listening and learning state. So that is the forward delay timer. By default it is 15 seconds and it can be modified between 4 to 30 seconds. Then the third one is max age timer. The word itself, it is very clear, maximum. Okay, that means the maximum length of time that a switch waits before attempting to change the STP topology. Okay, STP topology, that means we already blocked in a STP, we already blocked a particular port. Okay, just imagine a particular port is blocked. Now due to some reason the other links were not working means, so it is going to wait a particular period of time. Then automatically it is going to recalculate, okay, the recalculation step. So this is so how long, okay, the STP protocol can wait means, so by default it is 20 seconds. So every 20 seconds, within 20 seconds it should get some update. If there is no update means, so automatically it is going to do the recalculation and it is going to find the alternative path. So the default timer is 20 seconds, okay, and the administrators can change this from 6 to 40 seconds. Now I am moving to the next slide. So in the next slide we can see what are all the states, okay, the port states, what are all the different types of states available. So totally there are 5 port states available. So if you take a port, okay, you can see the diagram here. So this is a switch. So in the switch I am going to have 4 ports. So this is a 4 port switch. Now for each port, okay, for each port, so we can have different states. So totally there are 5 different states available. Okay, so the first state is a blocking state, the second state is the listening state, third state is the learning state, the fourth one is a forwarding state, and the fifth one is the disabled state. Okay, totally there are 5 different states. So blocking state, listening state, learning state, and forwarding state. Forwarding state and disabled, okay, disabled state. These are the 5 different states available. Now, so we can see the 5 different states. Then in each state, so we are going for the operational details. So what is going to happen? Suppose if your port is in a blocking state, okay, so it is blocking state means, so forwarding the data frames not possible. So it cannot forward any data frames if it is in the blocking state. So this is what we saw in the STP protocol, the last step. It is going to block a particular port. So once the port is blocked, so it is not going to forward any frames, but it can receive. It can receive the BPDU. So receiving only. So the bridge protocol data unit, it can receive, but it cannot forward any packets, and also the MAC address table it cannot update. The MAC address table cannot be updated. So this is the blocking state. So the second one is a listening state. So in the listening state, okay, so the port cannot forward any frames, but whereas it can receive, okay, it can receive and send. So forwarding is entirely different. Okay, forwarding is entirely different from send, okay, sending the frame. Then no updates in the MAC address table. So if a port is in the listening state, same thing, forwarding is not possible, but it can send and receive only the BPDU, okay, not the data frames, okay. So it can send and receive the BPDU, that means the bridge protocol data unit, but whereas it cannot forward any data packet. So updating the table is allowed, that means the MAC address table will be updated. Same thing for the forwarding. So almost for forwarding, okay, it is going to be send and receive. So the BPDU, the port can send and receive. It can update the routing, the MAC address table, and forwarding the frames, yes, because this is forwarding state. So in the disabled state, you cannot do anything. It is completely administratively down. The port will be administratively down, so you cannot send the BPDUs, okay, you cannot update the MAC address table, and also forwarding the frames is not possible. So completely it will be blocked because this is the idle state. Okay, it is completely disabled. So this is regarding the different states and how the states are going to operate. Then the next slide, I am going for per VLAN spanning tree. Okay, now this is called PVST, per VLAN spanning tree. Suppose I have 5 VLAN in my topology, okay, in my network. So we take our college network. So we are having 5 different VLANs. Now in each and every VLAN we can have a separate spanning tree protocol running. So each and every, okay, the VLAN, okay, so we can have a root bridge and we can have a spanning tree protocol running in each and every VLAN. So this is the concept of pre-VLAN, so per VLAN spanning tree. So this is called PVST. Okay, so there is a root bridge elected for the spanning tree instances. So that means possible to have different root bridges for different set of VLANs. So in every VLAN there will be a root bridge running. So STP operates on separate instances of STP for each individual VLAN. Then if all the ports are in VLAN 1, then there is only one. Okay, so this is the concept is simple. If there is no VLAN, by default all the port is going to be in VLAN 1. So if you are making VLAN, separate VLANs, so you are going to have different spanning tree protocol. So this is called PVST concept. Different versions of STP. So there are so many different versions of spanning tree protocol available. Okay, so example RSTP, MSTP. Okay, so in the previous slide we discussed about the PVST. So there are so many different versions of spanning tree protocol is available. So you can see the list, a complete list of spanning tree protocol. It is given in the next slide. Okay, so different versions of spanning tree protocol. So STP, variety and description. So the description is given and the STP is given. So let us discuss one by one. STP, spanning tree protocol, PVST 802.1d 2004, then RSTP, rapid PVST plus, MSTP, MST. So these are all the different versions of spanning tree protocols available. So you can see one by one. Spanning tree protocol, so that is the original version. So the original 802.1d, okay, that is the original version of spanning tree protocol. Okay, so this is also called a common spanning tree, CST, and this is the base. So this is the base for all the other spanning tree protocol. This is going to be the base, and it is going to maintain a loop-free topology topology in the layer 2. Okay, that is a concept. So PVST, so we just now we discussed in the previous slides. So per VLAN spanning tree. So if you are having 10 VLANs, automatically there should be a 10 spanning tree protocol running in different VLANs. So PVST plus, okay, per VLAN spanning tree plus. So this is also okay from Cisco, that is 802.1d. So here also we are going to maintain okay a loop-free topology in different VLANs, and this is PVST plus is going to support port fast, okay, uplink fast, backbone fast, okay, BPDU guard, okay, BPDU filters, root guard and loop guard. So these are all different features they including. Okay, that is the plus. The plus stands for. So there are so many additional features are included with the PVST. So the next one is 802.1d 2004. So this is the updated version of STP standard. So incorporating IEEE 802.1w. So this is just an updated version of the STP standard protocol. Then RSTP, rapid spanning tree protocol, okay, or we can say 802.1w. So this is the evolution of STP that provides faster convergence than the STP. So comparing with the STP, RSTP is going to be very fast, rapid. Okay, the convergence speed will be very fast. Then PVST is available, PVST plus, in that we have rapid. So here automatically the convergence is going to be high with some other additional features like port fast, BPDU guard, BPDU filters, root guard and loop guard. Okay, so these are the things. So MSTP, it is multiple spanning tree protocol. So this is a IEEE standard inspired by the early Cisco proprietary MISTP, and this is going to map multiple VLANs into same spanning tree instance. So mapping, okay, so it is going to map multiple VLANs into the same spanning tree instances. Then the last one is the MST, okay, so multiple spanning tree. So this is actually, it can provide up to 16 instances of RSTP and combine many VLANs with the same physical and logical topology into a common STP instance, RSTP instance. So if you see everything, the concept is same. What is the concept? The concept is to have a loop-free topology diagram, but okay, the place where we are using is changing. Okay, so one set of protocols, it will be without VLANs. So one set of protocols in VLANs, and one set of protocols, okay, which is having some additional features. That is the plus, means it is having some additional features like port fast, okay, BPDU guard, filters, okay, root guard, loop guard. So all these things are included. Okay, so these are the different different versions of STP protocol. We covered only ordinary STP, that means the standard version of STP only we covered in this particular lecture. So in this slide, we are going to discuss about rapid spanning tree protocol concepts. So STP. So STP we are going to technically we are going to name it 802.1D. RSTP is 802.1W. Okay, so this is the technical identification, we can say the number. So 802.1D is a STP protocol. Okay, so the traditional STP protocol. RSTP is 802.1W. Okay, now, so what is the difference? What is the basic difference between these two? Okay, so you can see 802.1D, 802.1W. So almost the concepts, okay, most of the parameters have been left changed. Okay, there are plenty of things, it's common. Okay, but what is included in this? Okay, RSTP means, so RSTP is going to be very fast. Okay, the same spanning tree algorithm is available in both the STP and RSTP. So everything is going to be same. But what is that means? RSTP increases the speed of recalculation of spanning tree when the layer 2 topology changes. So the recalculation speed is very fast and also very fast convergence. Okay, so it is going to have a very fast convergence. So you can see much faster convergence so in a properly configured network. Sometimes it is a little as few hundreds of milliseconds. So it will take only very less time to have a convergence. That means to learn about the entire topology. And then, so once if you know how to configure the STP protocol, so configuring the RSTP protocol is not going to be a basic thing. Okay, so Cisco implementation of RSTP, it is going to be same. It is almost same like the STP. Then, so per VLAN also we can have. Okay, so per VLAN also we can have this RSTP concept. Now, the next slide is going to be a very important one. So if you are going for RSTP, what are the different ports? So different ports the different port states means. So in ordinary STP, we have 5 different states: disable, blocking, listening, learning, and forwarding. So these are the 5 different states for a port in the RSTP protocol. Sorry, in the STP. If you are going RSTP, so in RSTP, so they merge together: disable, blocking, and listening. So it is merged together as a single one, which is called the discarding. Okay, so discarding state. Listening, as usual, listening, and forwarding is going to be forwarding. So in the STP, if you take the port states, there are 5 different states available, whereas in the RSTP we have only 3 different states. Then the next one, the role of the port. So you can see in the STP spanning tree protocol, so you have 3 different roles. One is a root port, a designated port, and blocked port. Whereas if you see the RSTP, okay, so rapid spanning tree, so we have 4 different roles. One is a root port, a designated port, backup port, and alternative port. So this is the basic difference between the STP and RSTP. Now, so moving on to the next one, you can see here, so how to use this backup port or where to use the backup port. So backup port is not available in the STP, it is available only in the RSTP. So how to use or where to use means, you can see in this topology diagram. So there is a loop available here. So we have to choose any one as the root bridge. So S1 is selected as the root bridge. Then, okay, we have to go for the root port. The next step is the root port. Then we have to go for the designated ports, identifying the designated ports. So once the designated ports are identified, we are going for the alternative port. So the alternative port will be blocked. Okay, so this is as usual. So now we have the additional one is the backup port. So what is a backup port means? Suppose this is a single device. Okay, a single device is available. So the single device is connected. Okay, so hub is a device I am taking. So this device is connected with switch 3. Now, so there are 2 links available. So one link I am going to consider as a backup. Suppose if this particular link fails, so backup will be used. So this concept is available in the RSTP. Okay, so in our RSTP we have this particular state. Now, the next 2 slides we are going to discuss about some key terms. Port fast. Port fast and BPDU guard. Okay, so what is port fast, what is BPDU guard, then alternative to STP. So alternative to STP we already discussed. There are so many different flavors of STP is available. So we can use any one in that. But what is a port fast? Okay, so we have to discuss about the port fast and BPDU. So port fast means this is a feature. So we can enable this feature. Okay, so in the RSTP protocol. So this feature is going to, so that means a port, okay, if you are configuring a port of a switch with the port fast, okay, feature means you can see the port, okay, so the port transmissions from blocking to forwarding, okay, that means changing the state from one state to another state. That means blocking to forwarding state, it is going to be immediately avoiding 30 seconds delay. So by default there will be some delay available, but if you put the port fast feature, so from the blocking state to the forwarding state, okay, it is going to be like without any delay, so it is going to start. So that means changing the state of the port. Then you can use the port fast on access ports to allow the devices connected to these ports to access the network immediately. So this is going to increase the speed of the ports, okay, changing the state, okay, from one state to another state. So the port fast should only be used on the access ports. You have to use it only on the access port. So if you enable the port fast on a port connecting to another switch, so you risk creating a spanning tree loop. So you have to use it in a very handle the port fast feature in a very careful way, so that it should not create any loops in the networks. Then alternative to STP, spanning tree protocol, there are plenty of alternatives available. We already discussed a very big table, a huge table we already discussed. Okay, so in slide number, okay, I think slide number 30. So these are all the different versions of STP protocol available. Now, so there is one more alternative they are giving. Okay, they are talking about the layer 3 routing. So whether layer 3, so if you go for the layer 3 routing, it is going to allow the redundant paths and loops. Okay, so there will be more than one paths will be available. As far as routing is concerned, it is allowed. But whereas in the STP, that means in the layer 2, okay, that means the switches, it is not allowed. So without blocking the ports. So for this reason, some environments are transitioning to layer 3. So whenever expected a device connect with the access layer switches, that means in other words, connection between the access layer switches and the distribution layer switches would be the layer 3 instead of in the layer 2. So they are moving it from layer 2 to layer 3. So it's not a big concept, okay, because theoretically they are giving. So try to understand. So layer 2 concepts, they are moving to the layer 3 concepts, but in layer 3 the loops are allowed. Okay, the loops are allowed by using the access layer switches. So it's a very big lecture, so quite conceptual. There are plenty of things we discussed in this lecture. So I request you to kindly, at least you have to watch this at least 2 times. So then only you can understand, okay, you will get a clear idea about this. So the summary of the lecture is given in the last 2 slides. So whatever we discussed so far, so they are just making it a summary, and okay, and it is given in the last 2 slides. So this is the references, so you can refer these books. So whatever I covered here, it is not the complete thing. Okay, so we are just given, okay, like what to say, just a overall idea. So you have to, as a student, so kindly go through the other resources also, and you can update yourself. So thank you very much. Keep watching.